With word problems, you'll find that there are at least three types that are very common in similarity. They create similar triangles, and you'll find that the proportions you create help you to find something that's unknown in the problem. The first type is very common, using sun shadows to find the height of an unknown object, usually something that's very, very tall and that would be very difficult to measure directly. You can't just take a tape measure. Instead, you have to use something a little more clever. So in this case, and this is a method that was actually used many, many, many years ago to find the height of the pyramids, to give you a little context, you could do this with a flagpole. I think there's a problem in your textbook about a very tall cactus. It could work for anything that can cast a shadow. So the sun, if you measure at the same exact time of day, should create the same angle, and therefore your shadows should create proportional triangles. So if I know the height of the person and I can measure the height of their shadow or the length of their shadow, then I can use that to create a similar triangle and find the height of the unknown tall thing. And the proportion I would create is just the height over their shadow. And then for the human, I'm doing theirs in the second proportion, height over shadow. You could organize it the other direction, height over height and shadow over shadow, but this is how I decided to organize it. Now, this uses something called angle-angle similarity. If I know that two angles, in this case, this top angle and the right angle with the ground are the same, well, the third angle has to be the same because 180 minus angle 1 minus angle 2 is always going to give you the same value. So if this angle and this angle are the same, then the third angle has to also be the same. And therefore, if they have the same angles, they are similar triangles. So let's see a different type of word problem. Reflections also commonly create similar triangles because, especially light or objects, when they bounce off of something, generally create the same angle when they do so. So if a cue ball on a pool table or a hockey puck or a light bounces off of a mirror, it creates a picture similar to this one. So if I know those are the same, and in this case, we're going to be bouncing off of a straight wall, so these have to be meeting at right angles, then again, we have two angles that are the same, and we have proportional triangles, or similar triangles. In this case, I split up my triangles according to the object that's bouncing off of something, and the observer, or it could be just like where it lands or something that created the smaller triangle. And you'll see there's a lot of commonality from the first one, height over distance, in this case, height over distance. It's just that the smaller triangle, while dilated smaller, is reflected. Makes sense for a reflection. The last type of structure is this type of picture, and it could be common to a lot of different types of problems where you have two triangles kind of extending out from one another. There are two different ways that they might set this up. They might say that the top line and the bottom line are parallel, as in my first diagram. And if they're parallel, well, then this angle and this angle are alternate interior angles, and alternate interior angles are congruent, which means you have at least two angles with the vertical angle here in the middle, and that means that these are proportional triangles. Another way they might set it up is to say that you have congruent sides, and therefore, the 24 and the 8, so the corresponding sides are always going to be congruent if they're the same. So this actually is using a different property, but this is the side angle side similarity. You'll notice that these are very, very similar to how we did congruence postulates, but not all of them transfer over. In this case, angle is one that you can use for similarity, and side angle side is also one you can use for similarity. If you have a picture like this and you know that the two triangles are similar, one strategy that we haven't explored too much yet is to find the scale factor. So I'm going to find corresponding parts of the two shapes. So on the first triangle, I did the outside numbers. On this side, because they're congruent, it kind of doesn't matter which ones you pick. And you just divide, and that gives you the scale factor. And once you know the scale factor, you can conclude that one of these things is that many times larger or smaller than the other one. And then every other item is a multiplicative relationship. So you can either multiply to get to it or divide by the same 3 in this case. Whatever the scale factor is that you found, you'll either multiply or divide to get to your answer. I know that's a lot of thinking. We're going to look at some examples and some real life applications of how you might use this math in class.